we're going to talk about the two different ways that we can divide polynomials. The first way that we can divide polynomials is using long division. When we use long division, we're going to set it up just like a typical long division problem from way back when you first learned long division. Divisor goes on the outside, dividend goes on the inside. One thing you'll want to do is anywhere a term is missing in your polynomial, so this is a fourth degree polynomial, but the x cubed term isn't there. It's 0x cubed. 0 would be the leading coefficient. I do want to include that when I set this up. So anytime one of the terms is missing, still include it with a 0. That'll make our division a lot easier. All right, so if you forget how to do long division, our first step is to ask ourselves, how many times does 2x go into 4x to the fourth? Or another way of thinking about it when we're talking about polynomials instead of numbers is, what can I multiply by 2x to get 4x to the fourth? And the answer is 2x cubed. Because I'm getting an x cubed term, I'm going to put it over my x cubed term there. Then, just like long division, with normal numbers, we're going to multiply that by a divisor. But in this case, it's a binomial, so we're going to multiply it by both things. And we get 4x to the fourth. And when we take 2x cubed times -1, we get -2x cubed. And again, like normal long division, we're going to subtract those two things. This is where most mistakes get made, so I recommend turning this into an addition problem and changing the signs so you don't make a silly mistake here, because most mistakes I see are in the subtraction part. So that's step one. We're going to keep doing that until we get all the way down the line. This is a particularly long division problem, but you'll get lots of practice doing the same thing. So now we're going to ask ourselves, what can we multiply by 2x to get 2x cubed? And that answer is x squared. Now we're going to multiply x squared by that 2x minus 1. X squared times 2x is 2x cubed. X squared times -1 is -x squared. And then we're going to subtract that. And again, I recommend changing that to addition and changing all of our signs. So now we have 4x squared. Bring down the 4x. Same steps. New term. We're going to ask ourselves, what can we multiply by 2x to get 4x squared? And the answer is 2x. We're going to multiply that 2x by the divisor. And we get 4x squared minus 2x. Time to subtract again. We're going to change that to an add a -4x squared and a positive 2x. And that is 6x. Bring down the -5. This is where things start to get a little bit different almost. We're almost to the end here. Let me erase these arrows real fast. So now we want to know, how many times does 2x go into 6x? And that answer is 3. 2x times 3 is 6x. You'll notice that every time you go to multiply, that first term should match. So like in this case, 3 times 2x is 6x. That matches right here. That should always be the case, because that's how you're getting that number in the first place. So if something doesn't match up, something went wrong. When I subtract this, I get a -2. Now, 2x can't go into -2. There's nothing you can, well, I guess there is, but not a polynomial that you can multiply by 2x to get -2. So this is our remainder, or you can look at our line there at the top and notice that we kind of ran out of space. We already have our constants lined up. Now it's time for the remainder. So our remainder is -2. We don't write our -2. We write -2 over that divisor. So all these steps, just like long division with numbers, it might be helpful to even review long division with numbers before trying polynomial division, because they're really similar. So another one, similar, here's my dividend, here's my divisor. When we set up our dividend, I notice that there's no x squared term, so I'm going to put a 0x squared there. And then in our divisor, there's no x term. It's not necessary to put a 0 out here, but I do think it's helpful. All right, we're going to start off the same way. This time we are asking ourselves, what can we multiply by x squared to get 3x to the 4th? And that would be 3x squared. And because we're getting an x squared term, I'm going to put it over the x squared term. Let's try that again. All right, and so now when I multiply that all out, I get 3x to the 4th plus 0x cubed plus 15x squared. Then we're subtracting that. I'm going to get negative 5x cubed minus 15x squared. Then we're bringing down the next term, 4x. So same steps, different terms. What can I multiply by x squared to get negative 5x cubed? That's negative 5x. So now I'm going to multiply that negative 5x times all of these. So negative 5x cubed, 0x squared, and negative 25x. Again, always be careful with that subtraction. So this is going to become a positive, a negative, and a positive. So we get negative 15x squared and 29x. Bring down the negative 6. Same thing. Different terms. What can I multiply by x squared to get negative 15x squared? It's negative 15. Time for multiplying. We get negative 15x squared, 0x, and negative 75. And when I go to subtract that, I get 29x and 69. This is where we ran out of room. We just got our constant term, which means what's left is our, our remainder. So our remainder is 29x plus 69 all over that divisor, which was x squared plus 5. So this whole thing is the answer to the division problem. So that's long division with polynomials. There's also synthetic division with polynomials, which is way, way, way easier. However, it can only be used if our divisor is in the form x minus a number or x minus h. So it could be x plus a number. So x minus 3, this is a candidate for synthetic division. We want it to be linear, and we want there to be no leading coefficient. So x plus 4 would work, x minus 7, x plus 11, x minus 21. All of those would work. Things that wouldn't work is if there's a leading coefficient in front, like a 2x plus 7, or if there's an x squared or an x cubed or an x to the 4th, it has to be linear. That's when you can use synthetic division. So synthetic division, you can set this up a few different ways, but how I do it is I start with all my leading coefficients. So the leading coefficient of negative x cubed is negative 1. The leading coefficient of 4x squared is 4. There's no x term, so I need to put in a 0 where the x term would be, and then my constant term is 9. So your number of leading coefficients should be 1 more than your degree of the polynomial. So my degree was 3. There are 4 leading coefficients. So it's going to be 1 more than that. Then I put this number in a box. If we're dividing by x minus 3, that's called, we're going to see if it's a factor. But we're going to put the number 3 in the box. It's going to be the opposite. Basically, you're putting, if it's in the form x minus h, you're putting h in the box. So if our If our divisor is x minus 3, h is positive 3. And here's how synthetic division works. You're always going to bring down that first number, in this case negative 1. Then we're going to multiply that number by the number in the box. And that's negative 3. Then we're going to add down. 4 plus negative 3 is 1. Then we're going to multiply that by the number in the box. That's 3. Add down. Multiply by the box. Add down. So in our resulting polynomial, it's always going to be 1 degree less than what you started with. So we started with a cubic. We divided by something that was linear, which means our resulting polynomial, this, when I write it as a polynomial, will be a quadratic, x squared. So that's a negative 1x squared plus 1x plus 3, and 18 is the remainder. And we put the remainder over the divisor. In this case, our divisor is x minus 3. So much, much, much quicker than long division. But again, it only works when we're dividing by something in the form x minus h. So here's another example where we're dividing by something in the form x minus h. In this case, our h is negative 1. So that's what's going to go in the box. And then we're going to list our leading coefficients. So we have a 3x cubed, negative 2x squared, 2x, and negative 4. I'm going to bring down that first number, multiply it by what's in the box. Add down, multiply by the box. Add down, multiply by the box. Add down. Once again, we started with a cubic, so our resulting polynomial is a quadratic. Or you can work backwards if you want. The last number you get is always going to be the remainder, which means the next one is your constant term, which means this one is your x term, which means this one is your x squared term. So we have 3x squared minus 5x plus 7, and then our remainder is negative 11. And that's our resulting polynomial. We'll do one more example. Again, we can use synthetic division here. Our h is negative 3 because our factor is x plus 3. So negative 3 goes in the box. Our leading coefficients are 2x cubed, 0x squared, negative 1x, and negative 7. And bring down that 2, multiply by the box. Add, multiply by the box. Add, multiply by the box. Add. So again, that last term is your remainder. And once again, we have a quadratic. So 2x squared minus 6x plus 17 minus 58 over the divisor.